Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Shaliani binti Ahmad Johari from EC1104J. Today I want to present about the mini project for code ECG263 Soil Engineering Laboratory. Introduction. This mini project laboratory aims to demonstrate acceptable approaches for soil engineering problems while keeping limits in mind. It entails conducting inquiries into well-defined problems, locating and searching pertinent codes and catalogs, and performing standard tests and measurements. This soil categorization mini project must be complete in our immediate surroundings. We recommend collecting soil samples and doing soil experiments that may be related to soil mechanics, key principles, and describe the soil in terms of moisture content, particle density, particle size, grading and texture, field density and permeability for this mini project. Test 1 is the moisture content. The apparatus that I use is soil sample, water, balance and container. Next is the procedure for this test, which is water content. First, we need to weigh all the container and then record the mass. Next, we mix soil with the water. Then we put the soil into the container, about 50 grams for each. And then record the mass for M2. Next, we put the soil in the oven with 118 degree for 20 minutes. Then we take the soil from the oven and weigh and record the data in the table. So this is the result for this experiment. And then the discussion for this experiment is the Atterberg test is used to define the soil behavior. There is also a close relationship between the limits and properties of a soil, such as compressibility, permeability and strength. In conclusion, the objective of this experiment is achieved by determining the plastic limit of soil sample successfully. The test 2 is the particle density. For the apparatus is soil sample, water, balance and bottle with the cap. The procedure for this experiment is, first, we need to weigh all the bottle and then record the mass. Then we put the soil 1/3 of bottle and then weigh the mass again. And then we need to put the water in the bottle. And then we need to weigh the container and record the mass in the table. Then we need to leave it for 10 to 12 hours, and after that we need to put the water until full and then record the mass in the table. Then we need to remove the soil sample from the bottle and clean the bottle properly. Then we need to put the water until full and then weigh the bottle and record the mass. So this is the results that I got from the experiment and the discussion. Based on the data, I obtained that the specific gravity of soil particles is in the range of 0.41 to 0.44. The average specific gravity at the room temperature of 28 degree is 0.42, which is also the same with the corrected specific gravity at 27 degree. In conclusion, the objective of this experiment is achieved because I am able to determine the specific gravity of soil using a bottle which is 0.42 average. Next is test 3, which is particle size grading and texture. And the apparatus that we use is soil sample, set of sieve, balance and pen. First, we need to weigh the initial soil sample about 500 gram and record the mass. Then we need to weigh all the sieve with the different size and weigh the pen. Then we need to pour the soil sample on the pen. Then repeat the step with the different size of sieve. After that, we need to record the mass on the data. So this is the result. Next is the discussion. From this experiment, I have already done making the sieving test, which is I want to know the classification of soil sample. I also need to make a calculation for grading characteristic and also its composition in order to know the soil classification. I conclude that the soil sample used in this experiment is well graded since it passed all the criteria needed to be classified as well graded soil. Test 4 is field density. The apparatus that I use in this experiment is core cutter, balance, hammer, ruler and marker pen. First, we need to label the core cutter with the marker pen and then record the mass and measure the diameter and height of the core cutter. Then we need to choose the location to do the test and clean the surface of the field from the grass. Then we need to dig the soil and we need to put the core cutter with the hammer.
A few moments later.
We need to repeat this step for 3 core cutter.
A few moments later. A few moments later.
And then we need to weigh all the core cutter with the wet soil and record the mass in the table. So this is the result for this experiment. The discussion. Based on the data above, I obtained that the bulk density is the range of 0.10 to 0.14, while the average of dry density is 0.12. The conclusion is in situ soil bulk density and dry density may be calculated. Furthermore, when working as an engineer to assess the qualities of in situ soil, the field density test is highly important to use and comprehend. The last test is permeability. The apparatus that I use is soil sample, water, balance, carton and bottle. First, we need to weigh the mass of the bottle and then record in the data. And then label the bottle with 1, 2 and 3. Then we need to put the carton to avoid the soil sample from drop. And then fill the bottle with the soil sample and weigh the bottle and record the mass. And then label each the bottle with the water level as H1, H2, H3 and H4. Then put the water until level H1 and then start the timing. Repeat the step with the bottle 2 and the bottle 3 and then record the mass. Then this is the data for this experiment. Discussion. The following head permeability test is used to measure the permeability of intermediate and low permeability soils with permeabilities less than 10 meter per second. The conclusion: as a result, I am able to define the generally recognized procedure for determining the coefficient of permeability of silts and clay, identify the link between permeability and pore size in fine-grained soils, and measure the coefficient of permeability of silts and clay. That's all from me. Thank you for listening.